In this video, we're going to see a couple of simulations of SIR models. And here's our first one. In this particular case, we started with 12 infected, 138 susceptible. And we can see that as this progresses through, the black here are the recovered, the red are the infected, the blue are the susceptible. And there are pockets of susceptible people that appear not to be getting infected. And in fact, as this steps through the simulation, it looks like our number of infected people is actually going to start going down, and our number of recovered people is going to start leveling off here shortly. Now this is based on proximity, so a susceptible person can only get infected if they are close to an infected person, and then an infected person recovers after a certain amount of time, where there's a probability that they recover after a certain amount of time. And the simulation will run until everybody's either recovered or susceptible. So there's the end of the simulation, and you see kind of the typical shape. The infection grows and then slowly starts to decay. The number of recovered starts to grow and then levels off, and the number of susceptible looks like it follows some sort of exponential decay sort of pattern. So let's look at a simulation where the infection itself is more easily spread. So in this case, we started with 14, and then immediately it jumped up to 94. You see the number of susceptible is really, really small. We've only got maybe one guy hanging out here. Yeah, it looks like one. Oh, and it looks like he has now been infected. But we see the same basic shape. The number of infected increased and then is drastically decreasing as the recovery rate takes over. And this will go until everybody's recovered.